Objective 8.1, to be able to simplify exponential expressions. When you have an exponential expression, first of all, you want to look to see what your givens are. And here, if we look at our example here, x to the fourth times your quantity x to the negative fifth times x to the third to the second power, we can see that we have something to the second power, which means we have two of those items inside being used. So we're going to rewrite it with those elements present. Then, as we look at our pieces, we can see that we have items with negative exponents, and we know whenever we see a negative exponent, that's its way of telling us that it's in the wrong location. Right now, these are in our numerator. Really, they belong in our denominator, so we're going to reorganize them. At this point, we kind of want to combine our like terms and see what we're working with. Well, I have 4x's here, 3x's here, and 3x's here for a total of 10x's. In my denominator, I have 5x's here and 5x's here, so I have a total of 10x's. Well, if I have 10x's in the numerator and 10x's in the denominator, I can divide out 10 pairs of x's. Therefore, my simplified expression would be 1. Again, when we're thinking about our exponential expressions, here's our rules that we can talk about. When you have a like item of the same base, you're doing your product of your powers. You're actually adding how many do you have of that item. If you have something raised to a power, remember you have that many of that amount, so it's a multiplier. Same thing if you have multiple items raised to a power, make sure you're distributing that to each item. Our quotient power says if you have the same base, for items in the numerator and denominator, you're dividing out your like pairs, which is like subtracting your exponents. Same thing if you have a quantity to a power, you can look to see what they have and they're distributed just like your power property here. Remember, anything to the power of 0 is always equal to 1. And your negative exponents are telling you that they're in the wrong location. So if they're negative in the numerator, they belong in the denominator. If they were negative in the denominator, they belong in the numerator.